Welcome back, student. As usual, today we'll discuss about one important law, that is the Kohlaursch law. This is very important. This topic you might have introduced in your lower sections when you discuss about electrochemistry in class 11 and 12. In this PSC, this concept is very important. So, since editing of video take a lot of time and unnecessary time consuming, so we will just do a quiet discussion without editing. So the background noise and all these things you please try to avoid, right? So this Kohlaursch law, first important point is this Kohlaursch law, it is applicable to low concentrations and strong electrolyte only. One very important point. Kohlaursch law do not take place in a high concentration and a weak electrolyte. This is very important. Kohlaursch law takes place only in low concentration and for strong electrolyte it is very important. So these are the two formula, lambda m divided by lambda m minus k into c, and lambda equivalent minus kappa into concentration. So this is the two important when you go for higher study like a PSC and in the MSc you will come across this two, right? Okay, this K is nothing but it is a Kohlaursch constant. K is Kohlaursch constant, C is the concentration, and lambda m is the molar conductance and equivalent conductance, right? So this formula also very important. Now yes, so this Kohlaursch law, second point is Kohlaursch law in terms of molar conductivities. When you discuss in terms of molar conductivity, since I've discussed the molar conductivity formula is L equal to K into 10 raised to the power 1000, K into 1000 by C, right? So this is the molar conductivity. So Kohlaursch law state in terms of molar conductivity, it states that at infinite dilutions, the molar conductivity of an electrolyte can express as the sum of the contribution from its individual ion. It can be cation and anion. So suppose you consider any of the electrolyte. If you have any of the electrolyte, so you have a two half cell salt bridges and you have a voltmeter connection, and you have a lot of chemicals, sodium hydroxide or any of the electrolyte that use to pass electrocurrent. So in terms of molar conductivity, the Kohlaursch law is Kohlaursch law state that at infinite dilution, the dilutions occur when the electrolyte conductivity takes place, right, in the electrochemical series, in the electrolysis. So at infinite dilution, the molar conductivity of this is the molar conductivity of electrolyte can be expressed as the sum of the ion, all the ions. It can be cation and a contribution from the ions. It is calculated. So that is the Kohlaursch law. So here lambda m power is molar conductivity plus, and this is the V minus V plus, V plus and V minus, right? This one. This is the number of cations and anion that contribution in the electrolysis process, and lambda plus lambda minus molar conductivity of the infinite dilutions of cation and anion. It can be cation and anion, right? So this is the formula. With the help of this formula you can be able to calculate the Kohlaursch law of molar conductivities. And this Kohlaursch law is very important for calculating the molar conductivity. So I repeat, molar conductivity M equal to V plus. This V plus and V minus is number of cations and anions in the electrolysis, and lambda plus lambda minus is infinite dilution of molar conductivity of that can be cation and anion. Okay, so this is the two important points in the Kohlaursch law. It takes place in the low concentration and a strong electrolyte. At Kohlaursch law state in terms of molar conductivity state out at infinite dilution, the molar conductivity of an electrolyte can express as the sum of the contribution from its individual ions. It can be cation or anion. So this is the 2 points. Okay, so with the help of this, let us calculate. Suppose you have this is the calculations. Let me write here. Suppose you have a molar conductivity. Let's write. the molar conductivity of infinite dilution of solution of sodium acetate is 91.0, HCl is 425.4, and sodium chloride are 126.5 at 298 Kelvin respectively. You have to calculate the molar conductivity of the acetic acid at infinite dilution. So look here, since you know that you have a, according to Kohlaursch law, molar conductivity equal to V plus lambda plus V minus lambda minus, right? So this is the molar conductivity. V plus and V minus is the cation and anion. Lambda plus lambda minus is the infinite dilution of molar conductivity of the cation and anion. So the easiest way of calculation this is, you are going, the question asks what is molar conductivity. This is the big question, right? So what are the given? You have a yes, you have a sodium HCl is and sodium acetate and sodium chloride. So let us say you have a H lambda HCl. HCl is how much? 425.4. You have another lambda sodium chloride. Sodium chloride is 126.5. You have a lambda acetic acid is CH3COOH, right? But sodium acetate, so you have a sodium acetate. You have a sodium acetate is 91.0. So the question asks is, calculate the molar conductivity of acetic acid. You are going to calculate the molar conductivity of acetic acid, right? So let us say you have a, let me save here, okay, and let me write in this. You have a, let's say when you dissociate HCl, you will get H plus, sorry, lambda H plus lambda Cl, you will dissociate. Let's say this is equation number 1. And similarly, when you dissociate CH3COO Na, you will get lambda sodium plus lambda CH3COOH, you will get, right? So plus and negative. Yes, COO minus, not H. This is equation number 2. Or when you dissociate lambda, what is remaining? Sodium chloride. When you dissociate the sodium chloride, you will get sodium, lambda sodium plus lambda chloride. So this is the equation number 1, 2, and 3. So the question asks, what is the question? You have a acetic acid. You are going to calculate the acetic acid. So from this equation number 1 and 2 by 18, equation 1 and 2 and 3, you get equation 1 is what is the equation 1? Let us say you have a equation 2 is this, CH3COONA plus, you have equation number 1 is HCl, and if you minus, by calculating how you will get the what you will get, minus what is there, sodium chloride, right? If you minus this sodium chloride, let me change the color of the pen. Suppose, so if you minus this sodium chloride, what you will get equal to sodium chloride, and when you minus this, you will get acetic acid, right? CH3COOH. So this is the calculation. So this acetic acid, how much is the value? Acetic acid value is 91.0. plus HCl is how much? 425.4 minus sodium chloride is how much? 126.5, sorry, minus 126.5. So this value, if you put acetic acid 91.0 and HCl is 425.4 minus sodium chloride is 126.5. When you do this, you will get the when you calculate this plus and minus, this is just a plus minus. Let me write here. You will get approximately 389.9. What is the Siemens ohm centimeter mole inverse? So this much answer you will get. So this type of calculation, it is a very important. It is very simple. Here you have to, first thing you have to know that what is the value of acid and base, and you have to come about the question of molar conductivity of infinite dilutions. So in this way you can calculate. Here you have a molar conductivity of the acetic acid. So how you will get acetic acid, plus minus, you do it. After that you put the value. First write down the value HCl, sodium chloride and acetic acid. After that you put the addition and multiplication, and the question is this was the acetic acid. So in this way you can calculate and get the molar conductivity of the compounds. So this is Kohlaursch law. And the application of Kohlaursch law. How this application of Kohlaursch law, this is also very important. Kohlaursch law is help to in calculation of molar conductivity at infinite dilution of weak electrolyte, right? It can also be used in the weak electrolyte, and in calculation of degree of dissociations. It can also be used in the calculation of degree of dissociation of any of the compounds. So this is the degree of dissociation. The equivalent conductance of 18 degree of normal solutions of potassium chloride is 92.2, and for the infinite dilution of some temperature is 131. Calculate degree of dissociation. So degree of dissociation is, this is the degree of dissociation, right? Molar conductivity of concentrations divided by molar conductivity of infinite dilutions. So this is the value that give molar conductivity of equivalent conductance is how much? 18, and the normal solution of potassium chloride as 98.2 for the infinite dilution of the same temperature at 131. So when you calculate, you will get the questions. This is how you can calculate degree of dissociation with the help of Kohlaursch law. And 5 application is calculation of ionic product of water. Kohlaursch law also used for the calculation of ionic product of water, right? So these are some of the applications of the Kohlaursch law. Similarly, the another question you have the molar conductivity of the infinite dilution for HCl, potassium chloride, and CH3ClCO, okay, are HCl is 4.25 into 10 raised to power 2, potassium chloride is this, and CH2ClCO is this cement molar respectively. So you have to calculate the infinite dilution for the monochloroacetic acid, this CH3ClCOH. So similarly, same as, right? Here also you have a lambda m equal to lambda plus by lambda minus. This is the formula from the molar conductivity Kohlaursch law. HCl is, if you calculate dissociate HCl, H plus Cl, you will get equation number 1. If you dissociate potassium chloride, sodium chloride. So similarly as the last calculations, it will be here from equation 1 and 2, 1 and addition of equation 1 and 2 and subtract. So if you add HCl with this monoacidic potassium chloride acid minus potassium chloride, right, you will get this HK is minus and Cl is minus, so CH3Cl COOH you will get. So you have to simply add the value. HCl value is how much? HCl value is, you have a 4.26 into 10 raised to the power 25, and CH3Cl is 1.13 into 10 raised to the power 2 minus KCl is 1.50 into 10 raised to the power minus 2. So when you calculate, you will get this. So these are some of the calculations for the molar conductivity with the help of Kohlaursch law. If you have any problem, you can ask. We will discuss in the upcoming video. So this is all about your Kohlaursch law. Its definition, calculation, and its application is very important. So that's all for today. Thank you everyone for watching. We'll discuss in the upcoming video.